It doesn't look like it's quite where we want it to be. This one's right in the middle, so C is looking pretty good, but let's look for like at least one more piece of evidence. This one has another max between 0 and 1, so I should have another 0 on my derivative. And this one does not. This one has a 0 at A, but this doesn't have a min or max. I'm sorry, this one has a 0 at 0, and this does not have a min or max. So C is our winner here. So let's look for the behavior. Increasing, stopped, positive 0. Decreasing, stopped, negative 0. Increasing, stopped, positive 0. Decreasing, stopped, negative 0. Increasing, positive. Okay, so C would be the derivative for number 19. Okay, so I'm not actually going to write anything down here, so let's skip right to 23. The page. All right, 23. We've got a table, and the first thing it asks us is what is the interpretation of A prime? So I'm going to get that table right here. So here's what it describes us as. The following table of values, the number A of automobiles manufactured in the United States. So A prime is typically a rate of change. So when it asks for the context, just kind of throw the rate of change into the context and what that would mean. So A prime of T is the rate of change of automobiles per year. So it would be like the number of automobiles per year, how the production is either increasing or decreasing, what the rate of change is. So I'm not going to write that down, but you guys should be able to write things down like that, especially on the AP test. So estimate A prime of 1971. Okay, so here's 1971. What I'm going to do is I'm going to take the values at 70 and 72 and just do a secant line from those values. So change in A over change in T. So 8.83. So we're doing, let's see, A prime of 1971. So I'm going to do the automobiles in 1972 minus the automobile production in 1970 to get a nice little secant, and then 1972 minus 1970. Okay, so automobile production was 8.83 in 1972 and 6.55 in 1970. 2-year time span. All right, so this would be, what, 2.18 and then over 2, so that would be 1.09, and that would be in millions of automobiles per year. So that's an increase. Obviously, you can see you've got an increase in production. And then A prime of 1974, next it asks us if that appears to be positive or negative. So if we're looking at the table here, 1974, from 1973 to 1974, the production went down. And from 1974 to 1975, again, production went down. So I would say it definitely appears to be negative. Those values are decreasing as you go. And so I would say that rate of change is going to come out to be negative. Again, we can't make assumptions. That's why I asked if it appears to be positive or negative. Okay, 24, I believe, is using that same table. Given the data, which of A through C could be the graph of the derivative? Okay, so let's put this all up here again. So we are hoping for one of these to be the derivatives, but again, which could be, doesn't mean it is. So it looks like we've got a pretty steady increase between 1970 and 1973. Okay, so this appears to be increasing all the way to 73, so this is an option. This is a definite decrease, that's out. And this one increases, but then does a sharp decrease. So I'm thinking that this is probably not it. Let's kind of see if this makes sense here. So then it looks like there's a decrease between 73 and 75. And that's what appears to be happening here. And then there's an increase from 75 to 76. So this seems like a pretty good estimation here. All right, so yeah, we're going to go with A. A would be the derivative. And you could explain all the things that I was just saying, that, you know, the values seem to be increasing. Oh my goodness, I just answered that as if that was a graph of A. Okay, hold on, I need to change my answer. Because the derivatives should either be positive or negative. Okay, let's try that again. From 70 to 73, A is increasing, so A should be positive, like above the x-axis. Okay, so this is out. This is in. This is in. Okay, so, and then the decrease happens somewhere around here, somewhere around 1973. So you can see it dips back below the x-axis somewhere around here. Okay, then it decreases for a little while, decreases maybe till 75, and then it starts increasing again. So my derivative should be negative for a bit, but then it should go back positive. This one's negative for a bit and then goes back positive, whereas this one stays negative the whole time. So it is B. I apologize. I hope that did not confuse you too much. I was originally answering as if that was A, but we should be answering as if it's A prime. I apologize. 29 to 34 is our next segment here. So these are just a whole bunch of derivatives. So we'll write down this function. We're just going to get some practice with power rules, constant multiples, product, quotient, all the good stuff. So y prime, constant multiple rule says the 3 just stays here while I take the derivative of x to the 5th. So 3 stays here. The 5 comes out fronts, and then I subtract 1 from my power to get 4. Minus, here the 7 just stays there. The 2 comes out fronts, subtract 1 from the power, plus, and then 4 is just a constant, so the derivative would just be 0. So let's clean this up. We're going to have 15x to the 4th minus 14x, and then I don't need that 0. Okay, here I start with the constant multiple rule again. The 4 is just going to multiply by whatever my derivative is. Power rule says the negative 3/2 comes out front as my new power, or as my new coefficient, I'm sorry, and then my new power, I subtract 1 from my old power. Okay, let's clean this up. Negative 6x to the negative 5/2. Okay, this one is just a demonstration of the power rule. The old power, whatever it is, comes out front. Doesn't matter if it's decimal, fraction, irrational, whatever. And then I just subtract 1 from my power to get the new power. Okay, y prime for this one, constant multiple rule says the 4 stays right there while I take the derivative. 2 comes out front as a coefficient, and I subtract 1 to get my new power. Minus, okay here, negative 2 comes out front as my coefficient, and I subtract 1 to get my new power. Clean this up, we get 8x plus 2x to the negative 3rd. Okay, here's a quotient rule with this one. So I want you guys to keep yourselves organized while you're doing product rules and quotient rules. That way you know where all the pieces are. So high, we've got x plus 1. That's the numerator. Low, we have x squared plus 1. That's the denominator. D high, that denotes the derivative of the numerator. So this is linear. Our derivative would just be 1. And then D low is the derivative of the denominator. Derivative of x squared is 2x. Power comes out front. And then plus 0. So just a 2x there. So my derivative, y prime, my rule is low d high, so x squared plus 1, and then just times 1, minus high d low, and then all over low low. Okay, so we want to do a little bit of cleanup, especially in the numerator. So here, this is just x squared plus 1. Here I can distribute the 2x, and I get 2x squared plus 2x. So let's combine like terms. X squared minus 2x squared gives me a negative x squared. Nothing minus 2x. And then 1 minus nothing. And then this, I would not attempt to FOIL that out. Just leave it exactly the way it is. So your derivative will look like that. Okay, we got 34 as well. Okay, 34, we got another quotient rule. Okay, so the numerator is 3t minus 2. Since it's linear, its derivative is just 3. Oops, not d low, just low. The denominator is 4t minus 9. Again, since it's linear, its derivative is just 4. So let's combine all that up in the quotient rule. So y prime, low d high, minus high d low, all over low low. Okay, so let's do some distributing, some combining. So multiply this by 3, multiply this by 4. Okay, so when I subtract up in the numerator, the 12t's will cancel each other out, and I'll have negative 27 minus negative 8. So plus 8 will give me a negative 19. And again, no need to FOIL out or do anything with that denominator. So this would be your derivative. Okay, next we're jumping all the way to 85. 85 has kind of like this set of using generic product rules and sum and difference rules and things like that. So my function here, I've got s of x equals 3f of x minus 2g of x. The AP test loves doing this, like generic derivatives. So it's asking you to find the derivative using the table of values. So s prime, constant multiple rule says the 3 just stays right here while I take the derivative of f. So again, generically, all I'm going to do is write f prime. And then minus, the 2 stays out front while I take the derivative of g. And again, generically, I am just going to write g prime. Okay, so now, when I come off the table, they're asking me for the derivative at x equals 2. So s prime of 2, I'm just going to replace my x's with 2's and then pull the values right off the table. Okay, 3 times. Now f prime of 2 comes right off the table. It's negative 3. Minus 2, and then g prime of 2 also comes right off the table. It's 9. So I have negative 9 minus 18. That leaves me with negative 27. Okay, we're also doing 86 and 87 in that same section. So 86, we've got a new function h of x, and it is f of x times g of x. So this is asking us to do basically a generic product rule. Okay, so the first function is f of x. Its derivative we can generically write as f prime. The second function is g of x, and again we can write its derivative just as g prime. So for h prime, we do 1d2, so f of x times g prime of x plus 2d1, so g of x times f prime of x. So this is just the product rule, like that should look familiar to you. So again, we're specifically looking for the derivative at 2, so I'm going to replace all these values with 2's and then just grab the numbers right off the table. So f of 2 is 5, g prime of 2 is 9, g of 2 is 4, and f prime of 2 is negative 3. So I end up with 45 minus 12, which is 33. Okay, so it's very important to be able to know how to do these generic ones like this. And last one, 87, is a generic quotient rule. Okay, so for r prime, we do low, d high, minus high, d low, and then all over low, low. Okay, so that's the generic quotient rule. I want the derivative at 2. So I'm going to plug the 2 in everywhere. Okay, and then just like before, I can pull those values right off the table. So g of 2 is 4, f prime of 2 is negative 3, minus f of 2 is 5, g prime of 2 is 9, and g of 2 is 4, and I square that. Okay, so I have negative 12 minus 45 over 16, so that gives me a negative 57 over 16. Very nice value. Okay, just a couple more left. So I've got 91. So 91 says find the points on the graph whose tangent line has a slope of 10. So let me write down that equation first. So being able to answer questions like this is super important for the AP test. So we want the tangent line to have a slope of 10. So what we're looking for is we want values of the derivative to be equal to 10. So in order to answer that, I have to find the derivative first. So f prime, derivative here, the 3 comes out front. subtract 1 from the power to get 2, minus 2 comes out front. It's going to multiply by the 3 that was already there. Power drops down to 1, plus